Hello dear students of plus 1, medical and non-medical, respected teachers. Today I am going to discuss projectile motion when we project the projectile with some angle theta with the horizontal. That is, I will discuss angular projection. So in angular projection, so we know when a body is thrown with some initial velocity at some angle theta, it follows path like this. Suppose OX be the x-axis, horizontal axis, OY the y-axis or vertical axis. Suppose projectile is projected from O at angle theta with the horizontal, then it follows the path OAB. If we neglect A resistance, so path will be symmetrical. Then this U, velocity, initial velocity at point O can be resolved into two rectangular components, U cos theta along x-axis and U sin theta along y-axis. Suppose Pxy be the position of the particle at any instant, x coordinate, this is y coordinate, and v the velocity of the particle at that instant, then it can resolve two components, vx vector and vy vector. Let beta is equal to angle, which is the velocity at any instant makes with the horizontal. A is the highest point and which belongs to the maximum height attained by the projectile from the level of projection. Now at A, vertical velocity component is 0 and there is only horizontal component u cos theta. Then it strikes the point B. So we have to find its trajectory, shape of trajectory, time of flight, its horizontal range, greatest height, and velocity of the particle projectile at any instant. So we will derive all these equations. Now we know that as soon as the projectile is projected, it comes under the action of two motions. One a uniform motion along x-axis, which is u is the velocity along x-axis, and other is uniformly accelerated motion along y-axis. It is velocity along x-axis remains same because there is no acceleration. So u cos theta. So u cos the velocity of the projectile along x-axis, it remains same everywhere. But as projectile goes from O to A, its velocity decreases, vertical component decreases and becomes 0 at the highest point. And when it comes from A to B, its vertical component again starts increasing due to value of G and it strikes the point B, and this OB is called horizontal range. So first we have discussed trajectory of the projectile. What type of shape of the path followed by the projectile. For this, using simple equation of motion s is equal to ut plus half at square. So because at an instant p x coordinate is the distance covered in the horizontal direction, y is the distance covered in the vertical direction. So using s is equal to ut plus half at square, x horizontal distance covered by the projectile after time t is given by initial velocity u cos theta into t plus 0 because there is no acceleration along x-axis. So from here we have t is equal to x upon u cos theta. We will use this value of t, say equation number 1. Now vertical distance y is given by initial velocity u sin theta at O into t minus half gt square. Why minus? Because in the vertical upward direction body is going opposite to value of g. So y is equal to u sin theta, substitute value of t x upon u cos theta minus half g t square means x square upon u square cos square theta. So this one u cancels, sin theta cos theta is tan theta, so it comes to y is equal to x tan theta minus kx square. This g upon 2 u square cos square theta is known as k. So y is equal to x tan theta minus kx square. which is nothing but equation of a parabola. And this parabola is symmetrical to an axis parallel to y-axis. So it is symmetrical to this axis, vertical axis, which is parallel to y-axis. So it means shape of the path followed by the projectile when it is fired at an angle theta with the horizontal or trajectory of the projectile is a parabola, which is symmetrical to an axis parallel to y-axis. Then time of flight. What is time of flight? Time taken by the projectile to reach from O to B. So B is the point on the same level of projection. So total time of flight, time taken to cover this path OAB. And using again S equal to ut plus half at square. Now, while going from O to B, what is the vertical distance covered by the projectile? 0, because O and B are at same level. So net vertical distance covered by projectile is 0. So it means initial velocity in the initial direction u sin theta into capital T instead of small t, time of flight, minus half g capital T square. So transposing half gt square is equal to u sin theta into t on t cancels, or t comes out to be 2 u sin theta upon g. So which is the required expression for time of flight of the projectile in this angular projection. So it means time of flight depends upon initial velocity of projection and angle of projection. Now, this is the time of flight. Now, time taken to reach the highest point, that is A. This is the time of ascent, and time taken by the particle from A to B is known as time of descent. Now let us calculate time of ascent and descent and what is the relation between them. To find time of ascent, using V is equal to U plus AT. Now, because vertical velocity at A is 0, initial velocity is U sin theta and distance covered is h. So we have final velocity is 0, V is 0, 0 is equal to U sin theta initial velocity minus GTA, or Ta is equal to U sin theta by G. So it means time of ascent is equal to U sin theta by G, or total time of flight is 2 U sin theta by G. It means time of ascent is equal to half the time of flight. And therefore similarly we can find time of descent. T is equal to T minus Ta, 2 U sin theta by G minus U sin theta by G, U sin theta by G. It means time of ascent is equal to time of descent. It means जिन्ना time ਉਹਨੂੰ O ਤੋਂ A ਤੇ ਜਾਣ ਲੱਗੂਗਾ ਉਹਨਾਂ time A ਤੋਂ B ਤੇ ਆਉਣ ਲਈ ਲੱਗੇਗਾ. Neglecting air resistance neglect ਕੀਤੀ ਹੈ. So time of ascent is equal to time of descent. Then we have to find maximum height. Maximum height attained by the projectile from the level of projection is h. It is also called greatest height. So again, using formula v square minus u square equal to as, you have used all the equations of motion. So in the vertical height, v by 0, 0 is equal to initial velocity u sin theta, 0 minus u square sin square theta is equal to 2gh, or h is equal to u square sin square theta upon 2g. So this gives expression for greatest height. H is equal to u square sin square theta upon 2g. So it means greatest height also depends upon initial velocity of projection and angle of projection. So more is the angle of projection, more is the greatest height. Then horizontal range, OB, maximum horizontal distance covered by the projectile from the point of projection. So is given by R. So as using S is equal to ut plus half at square again. So S is equal to R, horizontal distance, horizontal velocity u cos theta into capital T, and half at square is 0 because there is no acceleration along x-axis. So calculating R is equal to u cos theta, substitute value of time of flight 2 u sin theta by g. So it will be u square upon g 2 sin theta cos theta. So 2 sin a cos a is equal to sin 2a, or sin 2 sin theta cos a sin 2 theta. So R is equal to u square upon g sin 2 theta. So which is required expression for horizontal range, capital R is equal to u square upon g sin 2 theta. It means for R to be maximum for a given velocity of projection, theta is equal to, when sine to maximum is 1 or sine 90 1, it means theta should be equal to 45 degree. When theta is equal to 45 degree, R maximum comes out to be u square upon g. So sine 90 is 1. So very important question. It means for horizontal range to be maximum, angle of projection should be equal to 45 degree for a given velocity of projection. And this principle is used when we throw discus throw, in javelin throw, in hammer throw. So athletes use this principle because when they use technique and they project the discus or javelin or hammer at an angle of 45 degree with the horizontal, it covers maximum range. So to become winner, so this technique is used, because if you will increase the angle, greatest height will increase but horizontal range will decrease. But we need more horizontal distance to become a winner in this athletics. So R maximum. So very, very important. Also we can say that if theta is 45 degree, either it with the horizontal and with the vertical, 90 minus 45 is also 45. It means there are two angles for the same horizontal range. There are two angles for same horizontal range. That is theta 30 degree suppose, then 90 minus theta will be 60 degree. So whether angle is made with 30 degree with horizontal or vertical, range, horizontal range will be same. So there are two angles for same horizontal range. So because when theta and 90 minus theta becomes 45 degree equal, then it covers the maximum horizontal range. Velocity of projectile at any time, v is equal to under vx square plus vy square, or vx is equal to u cos theta, vy is equal to u sin theta minus gt, or substitute value of v is equal to under u square cos ka theta, u square sin theta plus g square t square minus 2ab, 2 u g d sin theta, or if we take u square common, cos ka theta plus sin square equal 1, so v is equal to under u square plus g square t square minus 2 u g t sin theta. At beta is the angle which v makes with the horizontal, then we can find tan beta, vy upon vx, u sin theta upon minus gt upon u cos theta, so tan theta minus gt upon u cos theta. So from this we can find direction as well as velocity of the projectile at an instant. When projectile strikes point B, then take t is equal to capital T and you substitute the value of t. This factor will cancel, so you will get v is equal to u square and root, or v is equal to plus minus u. And tan beta is equal to tan theta minus substitute value of t, simplified, it will tan theta minus 2 tan theta, or it will be minus tan theta or tan of minus theta, that is beta is equal to minus theta. So it means at point B, projectile strikes with the same speed but in the opposite direction. Here is angle theta, it will make angle minus theta with the horizontal. So this is all about angular projection. Its time of flight, trajectory, latest height, time of ascent, time of descent, horizontal range, velocity at any instant, and its direction. So one thing is very clear, that in angular projection, the particle strikes the opposite point after covering a horizontal distance from the point of projection at an angle of minus theta, but with the same speed but in the opposite direction. So this is all about angular projection. All the best, be happy, stay tuned for next video. Good luck.